Now, if we take a look at this problem, notice, again, all we've dealt with so far is substitution. You guys have all taken Algebra 1 and Algebra 2, so you know what elimination is. You've seen it before, but it's probably been a while since we used it. But if I was using substitution, again, I'm looking for that coefficient of 1. 3, 2, 4, 3, there's no 1s there. So substitution, if I had to use substitution, wouldn't be very pleasant in this problem. So the other technique for solving a system of equations is called elimination. And elimination is exactly what it sounds like. You're going to eliminate a variable, you're going to make it disappear. All right. You either make x disappear or you make y disappear. It is your choice which one you want to make disappear. It doesn't matter which one. You can get rid of x or y and get the answer. All right. What I look for, I'm looking for elimination, I'm looking for opposites. I want to make a number and its opposites, like 6 and positive 6, negative 6. Positive 10, negative 10. I want to make opposite numbers. So if I'm looking at these two objects, the y's and the x's, first of all, notice they aren't lined up. 3y plus 2x equals 7, 4x minus 3y. Y's over x, x over y, number over number. So the first thing I'd do, if this was in my book as a problem, is I would rewrite it like this. I'd go 2x plus 3y equals 7, 4x minus 3y equals 5. I like my x's to line up, and my y's to line up, my numbers to line up. Now notice I did rearrange things, but nothing moved across the equal sign. So 2x moved left, 3y moved right on the left side of the equation. So they stay the same sign, still positive 2x, still positive 3y. If you move them across the equals, now you're going to have to change the sign. So be careful about just basic rules of algebra like that. Now, for me, the word opposite, the first thing I look for is opposite signs. One positive, one negative. So the y's are feeling pretty good right now. And then we want opposite numbers as well. So positive 3, negative 3. The y's are already perfectly set up to eliminate. So this is the picture I'm looking for to eliminate. Okay? If it's there, use it. All right? If it isn't there, I could also get rid of the x if I wanted to. For this particular problem, I would not do this step I'm about to do, but in some of the problems you're going to have to do tonight, you'll have to do this step, so I want to show you how to do it. So, if I had decided instead of I want to get rid of y, I decided instead I want to get rid of x. So I decide these need to go away, and I need these to be opposites just like these are opposites. I would multiply by negative 2. Negative 2 times 2x makes negative 4x, the opposite of that. So the top equation would change to negative 4x. But then if I multiply this by negative 2, I have to multiply this and this by negative 2 as well. So I'm going to get negative 6y equals negative 14. The bottom equation would stay positive 4x minus 3y equals positive 5. There's my system of equations now. And now, through that modification that I made, those are opposites. So I can get rid of x very easily. Okay? And this is actually a technique if you want to find both x and y by elimination. If I eliminate y, I'll find x. If I eliminate x, I'll find y. My task is to find both x and y. So I could do this in this particular problem as well. All right, so if we go ahead and go through the process now that I've got set up, just the blue equations, don't look at the red stuff here. If I add these equations together, straight up and down the columns, 2x plus 4x makes 6x. 3y minus 3y cancels. Equals 7 plus 5 is 12. Because the y's are opposites, when you add them together they cancel, they make 0. X sticks around, the number sticks around, and you're left with 6x equals 12. Divide both sides by 6, so x equals 2. Okay. Now, if I hadn't done that over there, and I know x equals 2, the next thing I would probably do on this problem is go back up here, change this x to a 2, or change that x to a 2, and then solve for y using basic algebra. Since I went to the trouble of making opposites on the x's over here, elimination's quicker if you have it set up. So, over here, if I eliminate x, negative 4x plus 4x cancels, because they're opposites. Negative 6y and negative 3y, both negative, so I add to get 9y. They're both negative, so it's negative. Negative 14 and 5 are opposites, so I subtract to get 9. 14 is bigger, so it's negative. And then we divide both sides by the coefficient. And that gets me y equals 1. We found x, we found y, so the answer is 2, 1, and your answers should be ordered pairs on these problems. So make sure you write your answers in ordered pair every time. Okay. And again, if this hadn't happened over here, the remaining part of the problem wants to know x equals 2. I go back to either this equation or this equation, doesn't matter which one. I'm going to take the top equation and it would say 2x plus 3y equals 7, right? That's what the equation said before we started messing with it. 2x plus 3y equals 7. Instead of writing x, I'm going to write 2 because that's what x equals. 2 times 2 is 4. Move the 4 to the other side. Now all of a sudden 3y equals 3. You divide by 3, and y equals 1. So no matter how you do it, you're going to get y equals 1 because that's what y equals. One more point of order before I send you on to your homework assignment. Sometimes the number 0 shows up in these problems and it weirds people out. So let me just say this. If this said 6x equals 0, 0 divided by 6 equals 0. 0 is allowed to be an answer, all right? If in the process of doing that everything cancels out, let's say the y's cancel but then also the x's cancel, all of a sudden you have 0 equals 15 or 0 equals 0 or something like that. Those are the problems we haven't gotten to yet. So hang on to those problems if that should happen. If all the variables disappear in the process of doing one of these techniques, then stop. And then when we cover those problems next week, you will be able to handle those. They're not hard to do, they're just different, so we need to deal with those when we get to them.